All right, here we go with some more problems in which we are asked to solve equations that have logarithms in them and things like that. So let me kind of boil down kind of a general mind frame on what you can kind of do, like a mental checklist almost, that you can kind of do to help organize the chaos a little bit. All right. So the first thing that I would encourage you to do, if you can, is get a logarithm with everything in it equal to a logarithm with everything in it. All right. So nothing is outside. So if there's, like a 2 log x is equal to 1/3 log 27 or something like that. I don't know. What I want you to do is, if you can, put all exponents and everything up into the logarithm itself. So when all said and done, you have a singular log all in equal to a singular log all in. All right, so it's just pure log on the left and pure log on the right. All right. And if you are able to accomplish a situation where you have just a log equal to a log, what you can do is you can cancel the logs and just do the math of whatever's left. All right, so this would be x squared is equal to 27 to the 1/3. Okay, so that's what you would do. Okay, that's the idea. Is if you can get a singular log all in, singular log all in, and then you can just cancel the logs. And that oftentimes will be the case when you do literally have more than one log involved with a problem. Okay, so there's that sort of idea where we want to get a singular log all in equal to a singular log all in. Okay. Other situations is when you don't have logs on both sides. Okay, you only have one log in the entire problem. And so say, for instance, I have like 3 plus log x is equal to, what's like log base 5 is equal to 2 or something like that. All right, I'm just making this stuff up. A little bit bigger. Different number, 6. Okay, nailed it. Okay, when you have a log just on one side, so you don't have 2 logs in the problem. All right, my advice is isolate the log. Okay, get the log all by itself. Now, whether you need to put numbers up into the log or you just need to do some basic math, like here I would subtract 3, and that would isolate your log. Okay, and then so when you only have one log in the entire problem, get it alone, and then what you're able to do is you're able to rewrite it. So like, for instance, the base is the base. This is 5, and then everything switches sides. So 5 to the 3rd is equal to x, and then you can see that, okay, x is equal to 125. Pretty simple. So if you have just one log in the problem, get that log by itself and then rewrite it so it's no longer a log. Okay, so you like the base is the base, and then you just do some basic math. In problems in which you have a single natural log, okay, a single natural log. So similar to this problem, but it's not a log like a log. It's an ln. It's a natural log. All right, so in a situation where you have a natural log, like 3 plus natural log of x is equal to 6, or something like that. Okay, 1. Okay, If you have 2, again, do it how you have up in the upper left, where you get logs on both sides and you cancel them out. Okay, but here, again, what you want to do is you want to get the log all by itself. So again, some basic mathematics oftentimes is the key to accomplishing that. So I'm left with the ln of x is equal to 3. Now, it's a little bit more difficult to write it in this situation where, it's not like the base is the base. But don't forget our good friend e, all right? E eliminates ln. And e eliminates ln. So x is equal to e to the 3rd power, and Desmos is way capable of handling that problem. E to the 3rd power is 20.08, et cetera, et cetera, et cetera. Okay, now, what we're going to see a lot in these situations is where we need a singular log, like just one log and no funny business. So to accomplish that, we need the use of those log tricks that we learned in the last assignment. Like, so if there's an inside multiplication, that was an outside addition, and vice versa. Okay, an inside division is an outside subtraction. And then if I have an inside exponent, that's an outside just straight up multiplication. Okay, so you'll have to do a lot of these tricks to turn it into one log. So you can have like a singular log all in equal to a singular log all in. Okay, you'll have to sometimes do some of these tricks to make that happen. Okay, let's take a look at our problems. Solve the equation. Okay, so what I notice in this problem is I have a singular log all in, right there, singular log all in, singular log all in, okay? Singular log all in, there's not outside funny business. So what I can do is I can just eliminate these natural logs, which leaves me with the math problem of 5x minus 1 is equal to 3x plus 2. And then this is just pretty simplistic from here. So I subtract 3x from both sides, add 1, divide by 2. And there you go. Easy peasy lemon squeezy. Okay, here I have logs on both sides, but notice how that left-hand side is not a singular log all in. That's not a singular log all in. So what I need to do is I need to do some of my tricks to make that happen. I see that this is a subtraction, so that is the same thing as saying a division. Now I have a singular log all in equal to a singular log all in. So what I'm able to do now is cancel out those logs. That leaves me with x over 14 is equal to 5 over 14. And hopefully you can see the logic here that x is going to be equal to 5. 5 over 14 is equal to 5 over 14. Okay. Again, I almost have everything in these logs. Notice how I need to put up that 1/2. So this is log 8 of 81 to the 1/2 is equal to log 8 of x. But with that simple little adjustment, I have a log all in equal to a log all in. The logs drop. So this is 81 to the 1/2 is equal to x. That's the same thing as saying a square root. Or if you don't know that, you can just literally use your calculator here. Say 81 to the 1/2, and that's equal to 9. Uh-oh, here we go. All right, so I only have one ln. I only have one log. So what I'm going to do is I'm going to get this log all by itself, okay, equal to blah, blah, blah. And then when it's in ln, I'm just going to take both sides to an exponent of the e. All right, so how do I do that? I first get rid of the 4, so that's going to be a minus 4. Now I'm going to get rid of that outside negative, so I divide by -1. Okay, so I have ln of x is equal to 3. Now that the ln is all by itself, I take it to that e power. So the e gets rid of the ln, and now I'm left with e to the 3rd power. And what do you know, I actually did that problem just a little bit ago, and that's 20.2 decimal places 09. Okay, here I have a log on one side. So what I'm going to do is I'm going to get that log all by itself. Okay, so when all said and done, I'm going to be chilling with log x equal to something. All right, so normal math rules apply. I get rid of all pluses and minuses. So I'm going to add 4. I'm going to divide by 9. Okay, now, when I have a log all by itself, what I need to do is rewrite it. Okay, so let me write this just a little bit larger over here. So I have a log of x is equal to 5/3. Okay, so notice how they don't tell you a base. That's fine. This base, if they don't tell you, is a base of 10. Okay, is a base of 10. So when we need to rewrite it right here, the base is the base. So this is the base, so 10. And then everything switches sides. This is going to be to the 5/3 is equal to x. So the base is the base, and then everything switches sides. So this is going to be 10 to the 5/3, whatever that is. 10 to the 5/3. 46.42. Okay, here we have a log on one side, not a big deal. So let's go ahead and rewrite it. So 2, and then everything switches sides. This is to the 1st power, and that's equal to 5x. Okay, so doing the basic math, 2 to the 1st power is still 2. So this is 2 is equal to 5x. So pretty simplistically, all I need to do is divide both sides by 5. So it's 2 over 5, which is the same thing as saying 0.4. Okay, let's get one singular log. Okay, an addition implies multiplication. So this is log base 6 of 2x and x plus 3. All right, so now that I have a log all in on one side, this is when we rewrite it. So the base is the base, and then everything switches sides. Okay, so this is, long story short, 36, 2x squared plus 6x. Okay. Getting closer to the end, getting closer. All right, so what I'm going to do is I am going to subtract the 36 over here, so that will leave the left-hand side equal to 0. Okay, let's take out a 2. Huh. I don't see a simplistic answer here. Let me just graph this real quick. And I can use the quadratic formula, but long story short, what I do is I have answers of x is equal to negative 5.05, was that? 5.05. And then also x is equal to whatever this positive one is, 2.405. Take a look at that real quick on my answer guide, but yeah, I would anticipate that you're supposed to get good answers on that, but you know, I can't guarantee it unless I made a simple mistake somewhere. I think those are what they are. I'm sorry. I'm taking a look at my answer guide here real quick, see if I have to really hammer this down. Oh, duh. The problem is where did I learn how to do math? I took 36 and it turned into 13. I'm silly. Oh, great googly moogly. Spent too long today. All right, so this is a 2, which is x squared plus 3x minus 18 to you and I. Oh, gravy. So this is a 2x, 3 and 6. So positive, negative. So that means x is equal to positive 3 and negative 6. Okay, I'll just kind of mention it to you right now. Negative 6 is extraneous. And the only real rule about this and how I knew that one so quickly, that negative 6 is extraneous, is whatever you put on the inside of a logarithm, okay, whatever you put on the inside of a logarithm has to be positive. It has to be greater than 0. All right? And so if my x came out to be -6, which is a potential answer, notice that I cannot put -6 in for these things. If I were to put -6 in, that'd be the log base 6 of -12, which you can't have. All right, you can't have that. You can't have a log of a negative number. Okay. Didn't really want to get into the technicalities, but that -6 is extraneous. The 3 is good to go. The 3 is awesome, but the -6 is extraneous. All right, sorry about that. I should have been a little bit quicker with math on that one. Okay, here we go. Addition is multiplication, so this is log base 2 of 4x and x plus 1. Okay, log on one side, rewrite it. So this is 2 to the third is equal to 4x squared plus 4x. Okay, 2 to the third is 8. And so I'm going to subtract that. So 4x squared plus 4x minus 8. Okay, I can factor out a 4. I multiply to 2. Okay, -2 more specifically. And I need this to be a positive answer, so it's a +2 and a -1. So that multiplies to -2, but adds to a +1. And that implies that my x is going to be equal to +1 and -2. Again, looking back at the original problem, I need the logs to have positive values on the inside. So if I have a log 2 of 4x, and I have a log 2 of x plus 1, okay, am I able to plug in the number 1? So if I plug in the number 1, this is going to be log base 2 of 4. That's good. If I put in the 1 here, I have log base 2 of 2. Okay, that's good as well. Putting in the number -2, the first one would be the log base 2 of, -8. That's no good. So that's going to be extraneous. Okay, that's going to be extraneous. Same with the other one. It would come out to be -1, which again is extraneous. So the extraneous solution in this situation is -2, and I think that's what they're asking for. Yeah, what is the extraneous solution? Okay. X is equal to 2 is extraneous. Or it should be -2, my bad. -2. Okay, here we go. This is a division, so log base 25 of 4x plus 2 over 2x minus 1 is equal to 1/2. All right. Log on one side, rewrite it. So the base is 25, so 25 to the 1/2 is equal to 4x plus 2 over 2x minus 1. All right. 25 to the 1/2 is the same thing as the square root, so this is 5. What I'm going to do to start solving this is I'm going to multiply this out. Okay, so this is a 2x minus 1 being multiplied, so I have to bring in that 5. So this is going to be 10x minus 5. Okay, get all letters to one side. I'll subtract 4x, so that turns into 6x. And then I'll add 5, so that turns that into 7. X is equal to 7 over 6. Round your answer to 2 decimal places. different calculator for that. 7/6 is 1.17. Okay, last but not least, here we go. Subtraction is a division, so this is going to be log 2 of 9x over x plus 5. Log on one side, I rewrite it. So this is 2 to the third is equal to 9x over x plus 5. 2 to the third power is the same thing as 8. All right, so I have this big old division, so I'm going to multiply this out. Again, I have to multiply into the parentheses, distributive style. So this is 8x plus 40 is equal to 9x. I subtract 8x from both sides, so that leaves 1x is equal to 40. That's all she wrote. Again, logs on both sides, get everything in, then you can cancel out the logs. You have just a straight up log on one side, you got to rewrite it. Natural logs, get it by itself, and then you can take both sides to the e power. Okay, you have to obviously know all these tricks as well.